Hello and welcome back to Compiler Programming. Today we're gonna tackle a problem that is very commonly asked in the interviews, or at least used to be asked in interviews, which is Fizzbuzz. And there are a couple of language things that are missing in order for us to be able to even write Fizzbuzz. So we are gonna go through them and make that happen. So let's start very easily, and we would say that we have program import file prelude, that's fine. Instead of passing source here and doing all of this jazz, we are just gonna remove that as well, and we are gonna import the second file, which will be fixtures, and then Fizzbuzz, right? So let's create that file. This will be called Fizzbuzz, and I will take the hello world as an example because we definitely need these functions for Windows stuff. Eventually, this probably needs to be abstracted away into something better, but for now, that is okay. We will also be using a while loop, of course, and let's continue and see what we need to do. So one thing that is definitely missing for Fizzbuzz would be converting number to integer. So maybe we can start with writing that and see how it works out. And that in turn means that we need to have some way to define an array of a particular size. And that is also not something that is currently possible, so that's going to be interesting. I guess one way I could deal with that is to just define a pointer and then call dynamic allocation of memory instead of a static one. So I wonder which option is better, which option is worse. Well, I guess let's make a fixed size array. And one difference between C and what I have in mind is that fixed size arrays, they are not actually automatically decaying into pointers. So when you would have, so let's just start writing. We would say like buffer is gonna be, what is it, S8, and then we need to say the size of that. I also haven't figured out where to put the size, but right now let's say that the size will go here, and S8, I don't know, 32, there is probably the right size for turning integers into strings. That can only be so big, so I can probably look it up, but for now, I don't know. Let's have even a bigger size. Okay, so that's about the size, and I guess we only want to define it. It's not even a constant, and we will need to write into that. So something like buffer 0 is there is so much stuff that needs to happen for this to work. So maybe Fizzbuzz was overly ambitious, but let's see how far we can get into this. Okay, so first is we need a buffer. For that buffer, we will need to put some things into there, and right now I will not do literal, so we'll have to look up what is the actual number for different letters that we're going to use. So what is the basically ASCII code of 0. That's the problem. For now, I don't know, what's the fastest way? I'll just go to JavaScript and do it that way. So let's say that I want to do 0 char code at 0. So this is 48 to string 16. So it is 0x30. Okay, so we can do 0 code is 0x30. And this is what we will put here. So we'll say 0 code. And then we will put in here actual 0. And then we will try to, actually we don't even need this. We can somehow get the pointer to the buffer, which there is no syntax currently. How? Maybe for now I will go with the C one, although I'm not certain that would be the best long term. Okay, so buffer. And then we say that it only has one item. So if we can get this to work, then this would be great. Basically, we expect 0 to be printed on the screen. Let's see how it will work out, though. Okay, I can try to run the tests, and we will see some errors. Yeah, so first of all, we cannot find sum up to, that's fine. We will look for, we actually shouldn't be looking for main, so let's rename this right away. So this is going to be called Fizzbuzz, right? And this is what we will look for. And we don't even expect anything to be output. We just want to call the function. So this is function type, what is it? Void to void, right? And the name of it. So maybe I will actually do it this way and say that this is Fizzbuzz, and I'm just gonna call it, right? So this looks good. Let's try again. And yeah. So here's what is going on. We right now have no idea how to deal with this stuff. Let's try to find this code and see what we need to do about it. So this would be something like this, right? This is argument. This is actually not the code I'm looking for. And this is the one I'm interested in. Okay, so we have token rewrite definitions. And this needs to change. So right now it will be run as a last thing in the expression. So this is something that already started with I guess, if statement. So I was wrong about how to handle statements. Statements actually need to be handled first, but handling them first has its own interesting sort of points, I guess. So let's take this token rewrite definition. We will put it over here, and then I will also mark it so I can jump to this code. And let's figure out what we want to have. So if we were able to match this stuff, then basically the rest of the where am I? Here. We matched this, and then the rest of things here is the type. So instead of us just trying to match the identifier or single token, I mean, I could try to figure out how to make type in such a way that it always is a single token, but maybe that's not really great. So How do we do that? Well, we have state, right? And we have state start index. So let's do that. E64 I is actually, it's even easier. We can say array token pointer rest is dynamic array sub array token pointer and then we provide the index, which is going to be state start index plus peak index. And then we can say state. Actually, I need to probably look up what is the actual API of the dynamic array sub. What do I pass to it? I pass array type, array, and then the rest, which is range. Okay, good. So array type, then I say state tokens, and then it's going to be range U64, actually like this, of, so maybe I'll extract this into a separate variable and say that start index is this. And then the end is very straightforward. It's dynamic array length of state tokens. So something like that. And that should allow us to, again, extract all of these tokens. So it will be basically two tokens identifier and a square brace. Okay, that seems good to me. And now we need to match the, so somewhere we have something like match argument or something like this. Import match arguments. No, that's not what I want. Rewrite macro, rewrite functions, replace tokens, call arguments. Yeah, so this splits on comma and then it does dynamic match expression. That is for call arguments. I want just arguments. So this is, I guess, yeah, I guess we never made anything that is more precise than this. Well, that's fine. We can still make it happen. So there is this token first type. We definitely will need that, but probably it also exists here. Scope lookup type, yeah, and then if it's not an identifier, we say that it is, we try to force the value. Okay, this is for the label case. Okay, so that's also something entirely different that is also interesting, will be interesting to figure out, but for now that's not important. So as far as replace tokens goes, we basically want to replace everything in state. What would be the best way to do that? I guess the best way to do that would be to say state data length is 0. So something like this. I'm just basically clearing array without actually clearing the items because we don't care. We don't want to free memory anyway for now. Anyway. Okay, so we have this stuff and now we need to do some parsing on it. So let's do that. How do I want to handle that? Well, basically it's going to be the same matching as we have for regular expression stuff. I'm not sure if there are separate rules for that or they are the same ones. I guess they are slightly separate. Let's see if we need to make them not separate. So it needs to return what does it need to return? It needs to return a value, I guess. So it will do this stuff here. Value star token match argument expression or something, and it will accept this array token pointer rest or expression. Maybe it should actually get a token matcher state just so that it's consistent with all the other things. And it also, well, let's just give it all the stuff. Scope and builder because they'll probably need it. So let's say token matcher state rest state is well, we basically just need to give it tokens is rest, right? The rest is going to be 0 initialized and that's perfectly fine for us. Token match argument expression of rest state scope builder, something like that. We take this stuff, we don't need the match here. We will need this code in some form. And I also probably want some stuff from here. So we have this token rewrite expression, right? And we will do the same here, where we will say, for now I'll just have one. Token rewrite fixed array type, something like that. And this will be bool, token rewrite fixed array type. It will take all the same just as the rest of the things. Maybe it would be even nice to make a macro out of that, but that is not the priority for now, definitely. We can take something, for example, like this stuff here and start doing things. So how does it work? Well, for now, again, we're not going to do recursive case, I guess. And also associativity might be slightly wrong, but it doesn't matter. My goal for today is to get this stuff to work, and we can refactor later. So we have identifier, and then the next thing that we want to match is the square, right? Okay, and for this stuff, actually it definitely needs to be a type. So this would be actually interesting to deal with, I guess, but it's fine. Descriptor, okay. We look up type. And okay. And the next thing is we need to look into the square. So this is going to be type, and this is going to be size. Size token, I don't know. When we expect that size token only has one token, right? So we have dynamic array of size token children, not chicken, children is 1. Then we say token star size is what? Well, actually, let me think about this for a moment. We could just let it page and give it an expression and don't do any of that. And then if it's gonna be a constant thing, then we are gonna be happy. And if it's not gonna be constant, we're not gonna be happy. Should I do this? I should definitely, but maybe not now. So this is what I will do. Say fix me, allow any constant expression here. Okay. Now token star size is star dynamic array get of size token children, or maybe I should call it like square braces. Okay, yeah, that may be more explicit about what's happening. We get the zeros thing. We assert that size type is token type integer. And I think there was something about integer. I can just force value of integer. Okay, so that's fine. Where was I? I was here, so I can say value star integer is token force value of size, scope, and builder, I guess. We are asserting that integer descriptor or operand type is it should be immediate, but I think we have a nice helper for that. Something like is immediate. Yeah. So there is this nice thing here where which you can say operand is immediate of integer operand. And if it is immediate, is there also a way to get the right amount from the immediate? I guess not. Okay, well, it's fine for now. Fix me, allow bigger than byte. So this will go into fix me as well. I don't want to make this code too big right now. So instead I will say assert that operand type, like I'll put here, is operand type immediate 8. Okay. Now I actually can get the size. So S8. This is operand. S8 So this is now actually should be size token. Size token, and this will be size. And we say integer. I think it's like this. Integer brand, and I will just do immediate 8. Okay. So we finally have the size of this. We have a descriptor for the original type. We have the size. We are ready to make a fixed array. And I will just go here and look at how this is done. So let's take this stuff. Maybe it should be a helper. So another to do extract into a helper. And item is gonna be descriptor, right? And maybe we call it length. That's fine. So something like that. We now have descriptor for the actual thing, and we are ready to do this stuff. Actually, no, this is not important. That's an interesting question. What should this function return? Because this whole label business, it kind of messes up the expectation, I guess. Maybe it should actually I'm not certain. So it cannot really return. Yeah. This is awkward. So the problem is that we don't really have we have a token value, but we don't have a token type, right? So we don't have a way to defer the resolution of the type further. What do I want to do about that? Do I want to introduce new token type? Well, I guess that's what I will have to do, unless I want to hack it even further than this. And I might as well, I guess. Okay, so this is not what's going to happen here. How should I deal with this? Okay, this stuff expects us to have a pass over with the label rewriting, right? Yeah, we have token rewrite label here. So that's not what is going to happen, I guess. We have token rewrite label. What are you doing? So you are matching on a literal label, and then you're doing stuff. Okay, that is fine. I want to take you a bit up though, because I will use you here. and we can say token match end. So we actually expect it to be the last thing in the file. And then what? Well, we can change how it works. So it will work more like a standard parser, I guess, but it's fine. We would say label star. And if it doesn't match, it will turn 0 label. And if it does match, we will just return like this. Or we even don't need this label 32, we'll just do it like this. And then here we set this up, this is all fine. And we would say if token match label of rest state scope builder, then we do something with the label, right? Which I unfortunately, okay, this is the stuff. So we push this instruction. This even becomes simpler. Maybe label is, so I'll have to do it like this, I guess. Label star label is this. If label, and then return else. Okay. So define value. Do I need to still create a value from the label? And I guess I do, because I use that for the lookup later. So I shouldn't have actually removed stuff from here. Let me undo a bit so I can easily copy paste that code. Something like that. I don't want this stuff. I don't want this stuff. I want to do this. Okay. This basically always needs to happen. And then we basically return true. Yeah, something like that. Okay, so this is the case with the label. We want to have this code from here like this. And I can now say descriptor star token match fixed array type. So this is again going to be very limited, because it will only do non-recursive case, so we can't do arrays of arrays of arrays with this, but if it works with just this, that's fine. So I will put descriptor star here, and we return descriptor. And then I can say that descriptor star descriptor is 0, and if actually like this. Rest, state, scope, builder. And if not descriptor, then I basically expect that there is only one token there. So assert dynamic array length of I can use rest directly here is 1, and then token star type is dynamic array get of rest 0. We assert that type is token type ID. So this is like the complex case where we have the type and this stuff, and then there is a simple case like all others where we just have the type. Okay, so this is good, and now I can say that descriptor is this. Okay, so that was a lot of stuff. There is definitely something wrong with that code, and probably a lot, but let's figure that out. It's going to be called array descriptor. That's good. State, state, tokens, data length is state start index, something like that. Yep. Operand, yes, here should be label 32 of label or something. Yep. Value is reserve stack. So value star value, and then I missed this. So maybe, not sure what's better, copy paste or easier to read. Okay, that actually compiled, but let's see how it deals with the previous thing. So I will actually comment out the new test, because first I want to see if all the old stuff works. And all the old stuff surprisingly works, so we can continue with our adventures of the new stuff. The next tricky part is this, and it basically has the same issue, more or less, where we need to assign something to a particular position in the array. Well, before we do that though, so I will comment it out, and I will just let it print garbage. So ideally, when I run this, it should work, and it either will print nothing or it will print garbage. Probably it will print garbage because we would actually have stuff. No, I need to call a function before this. I'm not sure. Let's see what happens, but it shouldn't crash. That's basically the goal right now. So let's see. could not reduce an expression. Oh, we don't know how to parse hex literal. That's something to do, I guess. It's fine. And we don't know how to deal with at buffer. Well, that's actually easy. That is definitely something that should not take a lot of time. We would take something like negative literal. We would say that this is pointer 2, and I believe it has quite low precedence, but I'm not sure exactly how low. Definitely below function calls. So let's get this thing in, and I will say pointer 2. So what do we expect? We expect actually operator and, right? And then something, value token, right? And this doesn't need any special filtering, so literally anything can be on the right side of this. Okay, result, we force the value, and then we say that I think it's value pointer 2 or something. Let me pointer 2. So this is descriptor pointer 2. Isn't there like array value pointer 2? Value, so value pointer, reap value pointer. That's not what I wanted. Maybe it is in a different function. Maybe it is inside of here. Yeah, value pointer 2, so it needs a builder and the value. We can provide that. Builder and value. Okay. Integer is undefined. Yeah, that's fine. Value token. And then result. Value token. Okay. Let's see what happens now. Well, we didn't crash, and yes, so we got garbage, which is perfectly fine, because that was one of the options I was expecting to get. And basically what happens is we are pointing to an initialized memory, right? We could define something on the stack, but we haven't actually like put anything there. So it's natural that we will have garbage. Now let's continue. What I'm thinking is, do I want to go into trying to parse out this stuff, or I'm gonna cheese it and create a function for now? I think I'm gonna cheese it and not do it. So we can even add this, and fix me should be this, should be something like this. And instead I will have function called set array item, and it will not be even a function, it will be a macro, or like it will be a built-in compile time function. So we have set array item, we will provide an array, and we will provide the position, and we will provide this. In general, this might even be useful like for users later on, even if there is a syntax, and maybe we can make this be just a macro for this syntax. I don't know. We'll figure out. For now, I just want something easy because this video has been already going on for a bit, and we need to get at least to some resemblance of progress. So let's see. I definitely will not be able to finish Fizzbuzz today, but I want to output something like 1, 2, 3 into the console before we end this. So set array item. How do you want to deal with you? Well, well, let's see. So it will be another one of these, right? We will have a rewrite. It will replace 2 items with nothing, so it doesn't return anything. And we are matching with set array item, and then we are matching with type is token type paren. And that looks good. This is not what's going to happen. And I want to say array value pointer args is token match call arguments, and probably it gets all the same stuff. So scope builder. I want to assert that the length of args is 3. Then we would have value star array is oops, why can I put this stuff? Dynamic array length, dynamic array item of args 0. 1, 2, so this is array. The second is index, and the last one is value, right? And then I want to see if we actually fixed size array. Ooh. So it looks like we never actually tried to put things into a fixed size array, which is a bit scary, to be honest. We did it for structs, maybe. How do I want to do this? So here probably is in the struct field. No, is it here? Struct byte size. That's not interesting. I'm trying to find some tests where we are writing a field of a struct or something similar to that, because we need to deal with the offsets from the main one, and we need to make sure that we have the memory. This is short circuiting things. This is hello world. Maybe it is actually part of this thing. So let's look at this. Oh yeah, this is the stuff that I'm interested in. So we have the item byte size. Okay, that makes sense. Register for descriptor, so we have to put it into the okay. Yeah, so this was never fleshed out, so this is a bit worrying for me right now, but let's just plow on. Okay, we have register, temp descriptor. What is temp? Yeah, we don't want temp. The type of it, array pointer descriptor. Okay. Okay, gotcha. Now I understand how this works. Here it will be easier if we do this, I guess. So we'll get actually a pointer to the array, and then we would instead of temp, it will be here. So here we can say to do check for array type. For now, I'll just continue like this. Maybe do these checks of video. Okay, array index, we are moving it into reg A, that's fine. Then we create an indirect with this one and displacement. Okay, we can actually just use displacement. I'm not sure why am I not doing that. Because this should be possible to just say that I want okay, yeah, I guess I understand why that is not happening. So instead we are adding, so right now this will work only for bytes, so this will be another fix me. Actually that we can do, that is not too terrible. Item byte size is this thing, so that's actually okay. Okay. And I also want to have something like force integer or something like this. So we have this thing here with the definition. Yeah. So I guess I will just copy this code for now. And this will be rewrite set array item. Okay. This will be index. Yeah, we don't need this. Index. Index value. So something like that. This I'm not entirely certain because this was never actually tested. Displacement times item byte size. Right. So just a reminder, this way of addressing memory, we basically give it the base address, which will be, in our case, the address of the array, right? And then this is an offset in that address. and that offset is the size of the item times the index. You might even do this type of stuff in C when you do low-level memory management, so this is pretty standard way how to refer to a position in array. Don't really need this const. Okay, pointer. What else do I need to do? Well, I need to actually do something with that, and realistically what I want to do is I want to say move value, and this will be array descriptor pointer to. Okay, and I will say descriptor star item descriptor is this, because we need to actually create a value. We need to say value star target value is temp allocate of value, and then star target value is this stuff. So we have a value, we have operand, we have descriptor, yeah, and operand is this thing. And then we just move value, we provide a builder, and we move target value, something like that. Illegal indirection. Okay. Token match value type. Okay, this needs to be like this. Incompatible types, matcher state. What did you expect to get? Token star. I guess you expect to get it like this. Okay. And what is your problem? Get. Okay. It builds. The question is, what happens when we run it? Fizzbuzz, what are we trying to do? Yeah, I'm trying to put 0 at the first position. Let's see. Okay. That is because I didn't actually put it here. So let's do that. Doesn't really matter where we do it, I guess. Let's try that again. Okay, now that is a bit suspect. So we have set array item, we have paren, and we are replacing them with nothingness. So this should work. Yet it still complains that... Oh, yeah, I'm stupid. Token match, whatever, ID, and here I need to say type is token type ID, and then source is slice literal of this token type ID uppercase. Yep, let's see. Ooh, at least it didn't crash. And we even have 0. So as a final thing, so do I want to get ambitious or not? That's the question. Well, let's get ambitious. We say I is 0 while I less than 10. Let's get rid of this stuff for now. I just want to check if this even works. I is I plus 1. So I think we haven't checked that this works. Let's try to run that. Well, that loop seems to work. Okay, let's get more ambitious. We'll do set array buffer 0 code. So we would do it like this. And then here we would print 10. So chance of that working are pretty low, but let's see how lucky we are. Ooh. So what is going on? Something happens inside of here, definitely. And I wonder if it has to do with the scopes of things or something else. But regardless, I don't want to debug it right now. And this is gonna have to wait for the next video. Right now, I'll just do 0, 0 code and 1, 0 code plus 1, and 2 is 0 code plus 2. Something like that. If that works and we can print 1, 2, 3, that would make me very happy. And we can wrap up on that. Okay, great. We have 0, 1, and 2. This will be figured out some other time. For now, it is a bit less progress than I would like, but it is more than I expected once I realized that we don't really have anything that actually works to make Fizzbuzz, so that is still pretty good. I guess that will be it for today. In order to recap, now we support at least very basic option of putting arrays on the stack. We support setting the items of that array with a kind of a macro style thing that is built into compiler or compiler built-in function. Later on it will be turned into nicer code, but for now that's what it is, and that's okay. And we are able to print it, which is pretty cool. Okay, thank you very much for watching if you made it through this Turnips episode, and hopefully see you next time.